Okay, now global warming is at a level where it's almost equal to gravity in terms of its level of proof. In fact, there have been more talented, extremely smart scientists working on global warming probably than have worked on gravity in the whole history of it ever since Einstein came up with the general theory of relativity and the curvature of space-time and all that stuff that explains how gravity works. So it's one of the most well-proven things there is in science right now. I mean, if putting more CO2 in the atmosphere doesn't warm the climate, then when you put on a coat in the winter, it will not make you warmer either. I mean, it's the same, exactly the same principles of infrared radiation, the same equations, the same everything. I mean, you can't put on a blanket or a coat and get warmer and not have CO2 make the climate warmer. It just can't work that way unless you change the laws of physics. Happy to be here, and this is one of those old-growth hemlock forests that I've been studying. And as we'll see, the climate might be a problem for this. And as we'll also see in a minute, today's or yesterday's weather is just perfect for climate change because we do expect more big snowstorms, especially with the heavy wet snow with a warmer climate. From natural climate models, where we can project the climate ahead, the so-called global circulation models, you can start, one experiment that's been done is to start them in the year 1900 and run them up till now and see if you get what actually happened, which is the main way we know that these models work. But you cannot make them match what actually happened unless you put in the CO2 emitted by people in the model. So it's measurements of carbon dioxide concentration in the atmosphere. And as you can see, there's the little up and down each year. There's an annual cycle. That's caused by trees. Right? Trees during the summer take up carbon dioxide, and therefore by September we reach a low point, and then during the winter they're dormant. That's when Mount Pinatubo erupted. It was the biggest eruption in the last century. And what happened at the same time is that Gorbachev came to power in the Soviet Union, and the economy of Russia and Eastern Europe also collapsed that year, and people emitted less CO2. That's why it didn't go up as much. Here's a nice graph of temperature from about 1880 up to 2009. This is summer average temperature for the land worldwide, for the ocean worldwide, and land plus water. For people who think the 1930s had such hot summers, there are the 1930s. And here's the last 2 decades, much hotter than the Dust Bowl era. You can never go by what happens locally in order to judge global warming, because these cold spots, they're colder than average, drift around with those big swings in the jet stream. And here's what the temperature of the Earth looks like if you just put it into 10-year means. So each of these is a decade. And as you can see, the 2000s were the biggest upward step of any decade. This is a really good slide, although it only shows since 1980, so this is only about 30 years of reconstruction now. But what's really interesting is it shows the effect of all different things on the climate. For example, this green line here, with the ups and downs, that's the impact of the sun on temperature on the Earth. There is a sunspot cycle, which does cause temperatures to go up and down by about almost 1/10 of a degree. So that makes a difference of 1/10 of a degree, and that cycle just goes on over time. The overall trend, though, is flat. This light blue line here is the effect of temperature on the Earth from volcanoes. So volcanoes put dust in the air, filters out sunlight, it cools the world for 1 to 2 years afterwards. And then this dark blue line is El Nino versus La Nina. When it's an El Nino, the world's a little warmer, and you see the big El Nino of 1998 there. When there's a La Nina, then it's a little cooler. And then this red line is the impact on temperature caused by CO2 and other greenhouse gases emitted by people. All you have to do is add those 4 lines together and you get the orange line on the top graph, which is put on top of the thermometer record there in the black. So that you can see, we really can model almost exactly what the atmosphere does. I mean, the real record is just slightly more spiky. But as you can see, we can predict almost exactly what happened to the temperature as reconstructed from thermometer readings since 1980, just by knowing what El Nino volcanoes, sunspots, and CO2 emissions by people did. And the only one here with a systematic trend is that red line, which is the effect of humans on the climate. But when you put together all those ups and downs of all the other influences, you get this irregular. It does have an overall upward trend, but the fact that it's irregular and doesn't go steadily up confuses people. I mean, it's no different than the stock market, which, believe it or not, does go up over time. But it doesn't go up as a smooth line like this red line. It goes up like that. And then these are the simulations I told you about earlier that go from the year 1900 up to 2000. The black line here is the observed temperature from thermometers again. This blue color, kind of wide line there is when you run the model without the CO2 effect. And I know it's hard to see because it's washed out, but that very faint pink, which you can just barely see there, that is when you run the models with the CO2 effect in. So as you can see, you can only match what actually happened, which is the black line, when you include the CO2 effect in the model. This is about 2030, this is about 2060, and this is about 2090, okay? And these are predictions for a high emission scenario and a low emission scenario. This is the temperature scale, degrees Fahrenheit. So this is taking those same models that we were just able to duplicate what happened over the last 100 years and going forward. And so here is, for a low emission scenario by the late in the century, we're expecting here basically about 5 or 6 degrees Fahrenheit warmer temperatures. For the high emission scenario, which I'm pretty sure is the one we're going to end up following, we're there and we're in the 12 to 14 degree temperature scenario. So more big snowstorms, because here you can warm up the winter quite a bit and still be below freezing. And with more moisture in the air, you'll get more big snowstorms. So that's not a surprise. That's a prediction that scientists have made for global warming, that there will be more big snowstorms. And then spring is there, but what's really important for trees is summer. And these brown shadings are less rain, so minus 5 to 10% rain in the summer, combined with 14 degrees warmer, takes the climate of Minneapolis and makes it somewhere between Kansas City and Oklahoma City. So here's what happens if you just, this is future summers by 2095 and winters by 2095. So we do expect summers to warm up much more than winters, as you can see there, putting Minnesota down in the Oklahoma to southern Nebraska region, whereas winters would only get as warm as Wisconsin. Here are two projections of the future. This is from the British Meteorological Office, and it's a decreasing emission scenario if we somehow are successful with our 80% CO2 cut that you've heard about. By the end of the century, 1 degree Celsius warmer in this area, or 1 to 2 degrees, that would make us about like Des Moines, Iowa. With the business as usual scenario here, this is for mean annual temperature now, not by season, about 8 degrees, and this is Celsius actually, so 8 degrees Celsius is like 15 degrees Fahrenheit.